All right, I suppose we're here, okay? I suppose everyone can see it. That is the 3 questions on the homework, all right? Now, the first question is the best done question. Oh, but before I talk about individual question, let me talk about some common characteristics, common features I want to share with you what I observed in this homework, right? Now, number one, define your symbols. All right. Okay, so like for example, in this question, someone says that, well, the angle is angle EPX, all right, is something, all right? Now that unexplained x, what is x? I mean, where is the point x, all right? If you have a diagram like this, but you put angle EPX, so where is x, right? If the answer is correct, then I can understand the x is the point you talk about, all right? But if the answer is wrong, you make some calculation mistakes here or there, we have no idea to track what was your x, all right? So try to define your symbols. If you have those point x, point mn, angle theta, and so on, all right? You have to let the marker know where the theta is. You know, answering an exam paper is a process of communication. It's the process of communication. You have to tell the marker that what you are thinking, right? Part of that, actually part of your thinking is on paper. Part of your thinking is still in your brain, all right? You have to dump all the material in your brain onto the paper so that the marker will know what you are thinking. If you have undefined symbols like this, right, angle EPX, so what is x? Right, if you have undefined symbols, or you just write sine theta is 6 over EB, or something like that, then people will have a hard time thinking about what is your theta, all right? In this case, that is a mistake. 6 and EB is kind of like this. I don't think it goes into any sine theta, right? If there is a mistake, people will be very difficult. I mean, the marker will be almost impossible to identify where your theta is, all right? If it is correct, like sine theta is 6 over F BP, right? Then there is a slight chance that the marker will still understand what is the 6 and the BP, so that he or she may figure out what your theta is, right? If that's correct, it's okay. But if you make a mistake somewhere else, then it is impossible for the marker to understand you, all right? So to define symbols, now that is the importance to define symbols. But how do we do that, right? There are 2 ways. One is the hard way, one is the easy way. The hard way is to do it in writing. Let angle, what is that? EPCB theta, something like that, right? That is one way we can do it. All right, that is one way you can do it. Or you can do it like this. You can mark it on the diagram clearly, all right? This is theta, all right? And then you put a footnote in the writing of the answer with notations on the diagram. Right? Now, this is a key sentence to alert the marker to look at the definition on the diagram, but you have to write very clearly, all right? Or you can put down something like this, right? Sorry. You can put down, say, this is the midpoint, right? This is point P, all right? And then you, no, I use P again. This is point Q, all right? And then this right angle, something like that, all right? So you can use this statement with notations on the diagram to indicate, to activate all the markings on the diagram, but you have to mark it on the diagram clearly. All right, you have to mark it on the diagram clearly. Or you want to do it the proper way is to do it in writing. Write down all the symbols that you define on the what is that, on the description, all right? Or you can do it on the diagram. You can do it on the diagram, but saying that with the notations on the diagram, you kind of activate all the markings on the diagram. This is point Q, this is right angle, this is theta, and so on. All right. With one statement, you activate all the markings on the diagram. All right. Otherwise, the marker might not look at your diagram. All right. Without this statement, the marker might not look at the diagram. So with a statement like this or something like this, right? Then you have you can include all the markings on the diagram. Right. So that is the first thing. Define your symbols. Define your symbols so that you have a proper communication with the marker. That is number one. Now, number two is the abuse of the equal sign. All right. Like I said, there are still some of us did something like this. She says cosine theta is 0.6 is 53.13 degrees. All right. Some of us still do things like this. All right. When I say abuse the equal sign, you are abusing this equal sign. All right. Cosine theta is 0.6 equals to 53.13. I will understand that you mean theta equals to 53.13. But without properly write the theta, that actually means cosine theta is 53.13. All right. And that is not a correct answer. It should be theta equals to this one. All right. And similarly, when you say when you do cosine formula, you have AC squared is 2 squared and 3 squared minus 2 times 3 times cosine 30. All right, and that equals to 1.62. All right, something like that. All right. Now, once again, you are abusing this equal sign. All right. This 1.62, in fact, is not AC squared, but it is just AC. All right, but if you put the it in writing like this, it literally means AC squared. All right, so it's much proper to put back the AC here so as not to abuse the equal sign. All right, that is the second thing, second overall reminder on the homework. The third and the fourth one is more prevalent. The third one is to wrongly assume right angle is a wrong judgment. Especially on right angles. All right. Some of the questions, they are not right angle, but somehow you mistook them to be right angle. For example, in question 2, all right, this angle PQR is not a right angle. This is not a right angle. Yet, quite a number of us mistook this to be a right angle. It looks like a right angle, but it does not mentioned anywhere in the question it is a right angle. In fact, it is mentioned specifically that it is an obtuse angle. Right? PQR is an obtuse angle. It is not a right angle. All right. Yet some of us still misjudge this to be a right angle. And likewise, in question number 3, we'll talk about that later on, right? Some of us mistook this to be a right angle. Or some of us take the center line, all right? But she mistook this to be a right angle. All right. Now, once again, these are not right angles. Right? It looks like a right angle does not mean that it is a right angle. All right. So some of these misjudged. Now, this is a fatal mistake. This is a mistake with huge consequences. Because if you assume some of them is right angle, turns out to be not a right angle, then all your calculation goes haywire. All the calculation, they are wrong. So you can't just do that, okay? It's not just on right angle, right? Also on straight lines and on parallel lines. These are the most common things people misjudged. All right, right angles, straight lines. You have 2 line segment, right? It looks like a straight line, but if they do not tell you, don't assume that they are straight lines, all right? And also parallel, right? Parallel lines, straight line, and right angle. These are the things that many people misjudge, all right? So there's a wrong judgment, wrong assumption. The last one is misidentify. Like I said earlier, you calculated the wrong angle. All right, the angle should be angle ABC, yet you calculated angle ACD. All right, your calculation is perfect, but you calculated the wrong angle. You did the wrong angle right. Right now, sadly, that will score 0 mark in the exam. Right, because the question asks for that particular angle, and you calculate the other angle, even though your calculation is perfect. Right, but you spend a lot of time working on the wrong angle. So it's like Chinese or English composition. If you misjudge the question, if you work on the composition on the wrong topic, then you will score very low mark. All right, that is a misidentify. Right, it's a misidentification case. All right. All right. So let's look at this question one. Right now, remember these are the 4 common points we mentioned. I observed in the homework. Right. The first one is on properly defining your symbols. You can use your own symbol, but you have to tell the marker what the symbols are. And secondly, right, is a kind of a style in the writing. Do not abuse the equal sign. Make sure the things before and after the equal sign, they are the same. All right. Point 3 and 4, they are more important. Point 3 is on the right angles and parallel lines. Do not just assume they are right angle or parallel. The last one is the most important. It's the where question. It's the identification question. All right. So now let's look at question 1. Question 1 is finding about the angle between EP and the plane CDQP. Now CDQP is the bottom plane, in fact. CDQP actually is the ground level. All right. So we want to find the angle of the angle between the line EP. EP will be this red line. All right. EP will be this red line and the ground. All right. So to do that, we have we have a light, right, on top of the ground level, and then you cast the shadow of the red line. The shadow of the red line will be this orange one. No, let me this blue one. All right. The shadow of this red line will be this blue one. Right? The blue one is on the ground level, and the point E, the foot of perpendicular, drops to this point F. All right, this point F, and this is a right angle. All right, EF is vertical to the ground, so it is perpendicular to every straight line on the ground. All right. So we have this triangle, we have this angle. EPF is the required angle. All right. To put it in writing, we can let F be midpoint of BD. All right. The required angle is angle EPF, right? Now that is the proper way to express, to communicate with the marker, right? I try to first to define all the symbols, and I'm telling the marker, hey, I'm going to find this angle. This is my target, angle F, angle EPF, right? This is my target. For this question, some of us mistook angle EPD to be the answer, right? And that was wrong. Some of us mistook angle EPD as the answer, and that is wrong. It should be angle EPF, all right? The angle between the line and the plane is the angle between the line and its own projection on the plane, all right? The line EP will cast a shadow FP on the ground level, all right? And point F is the midpoint of BD. So the required angle will be this one, all right? Sometimes this will already give you 1 mark. Identify, if it is a difficult question, right? Identifying the correct angle will already give you 1 mark without any calculation. So the calculation for this one goes like this, right? We have a we have a right angle triangle in EPF. We have E, P, and F. Right? This is being a right angle, and we have E, F, P right here. So right away we have EF. EF should be 6 norm, right? It should be this one. It should be 6. As for EP and FP, we need only one because we need only 3 pieces of information. We have 1, 2. Now we need a third piece. All right. You can try to do it with the red line EP, or you can do it with the blue line FP. All right. So one way or another, we can get this angle. This angle, the answer will be 18.1 degrees, if I'm not mistaken. Let me check my answers. Right, it should be 18.1 degrees. You can do it through the red line, or you can do it through the blue line. All right. To find the red line, we need this green one. All right, we need the green line because there is a right angle triangle in here. So use the 6 meter and 20 degrees, we can find the green line. With the green line and this right angle, we can find the red line. Okay, we can do it like this. Or alternatively, you can do it on the ground level. In addition to the green line, you can find the blue line with this yellow one. All right, notice that that is also a right angle in FCP. All right, so in the triangle here, you can find out the yellow line using 6 meters and 20 degrees. You find out the yellow line. With the yellow line, you can find the blue line. All right. So with either the red or the blue, you can find this answer. Since most of us got it correct, so I'll talk about it briefly. So that is the first question. All right. Okay, let's move on to the next one. Now, it's more problematic in the second question, right? Almost all of us get it right for part A. Part A will be 80.0 in part A, right? The distance of PR. But then quite a lot of us make the mistake in the bearing. So let me stress again. The bearing of T from Q, in fact, equals to the bearing of P from Q. Forget about T, all right? We always use the ground projection of T. So what is special about P? It is the ground projection of point T, all right? So the bearing of T from Q is the same as the bearing of P from Q. The point P being the ground projection of T, all right? Now, the mistake I observe is that some of us calculate this yellow angle, all right? And she took maybe 90, maybe 360, and then subtract this yellow angle. And that would be the bearing, right, of T from Q, all right? Now, the one thing I observe immediately is wrong is that this yellow angle does not lie on the ground. It is a vertical angle. It is not an angle on the ground. And an important idea about bearing is that bearing is always on the ground. It sticks entirely on the ground. It's a flattened angle on the ground level. If the bearing angle is anyway lifted up from the ground, it is definitely wrong. All right, it's definitely wrong. So you have to be very careful about the bearing, right? The bearing is always on the ground level, on the horizontal level. Likewise, angles of elevation, angles of depression, they are always on the vertical plane. All right. So this, for example, this 32 and this 50, they are different in the sense that 32 degrees is a vertical angle, whereas the 50 degree is a horizontal angle. All right. So to find the bearing from T, the bearing of T from Q is same as to find the bearing of P from Q. So to find this bearing, we need to find this angle, this red angle, all right? It's going in this direction. The bearing is going in this direction. So the answer should be north, certain angle, right? That the red angle and is going to the west. It should be this one. As of how to find the red angle, we can use the three lines. We can use the focus triangle here. All right, we just got the focus triangle, PQR. Yeah, PQR. This is the focus triangle, and we have the three sides, right? Or do we have the three sides? No, we got only this one and this one, right? And we do have this angle. This green angle turns out to be 40 degrees, am I right? This green angle turns out to be 40 degrees. So we have an SSA situation here. SSA situation, all right? And we need to find the SSA, and we want to find the red angle using SSA, all right? But SSA, that may be the ambiguous case. There are two answers. There might be two answers in the SSA, all right? So now the second thing is how careful are you in reading the question? The question says PQR is an obtuse angle. So among the two answers, I choose the obtuse angle, all right? So I would say let angle PQR to be theta, all right? Or I mark it on the diagram, and then I put the statement with notations on the diagram, right? Or I put it in writing, let PQR to be theta. Then invoke the sine formula. We have sine theta divided by 80 equals to sine 40 divided by 52, all right? So the calculator will give you theta is, let me check my answer. What is theta? The calculator gives me theta is something like 81.5 degrees, all right? Now the problem is some of us took this as the answer. Some of us took this as the answer. So you make two mistakes for those who took 81.5 as the answer. Number one, you did not read the question careful enough. You did not read the question careful enough. All right? Angle PQR is an obtuse angle stated explicitly in the question. All right. Secondly, you do not aware that for sine formula, there might be an alternate solution, 180 degrees minus. All right. 180 minus. That is a huge trap for using sine formula to find the angle. So my advice is, if you have a choice, do not use sine formula to find the angle. Now, in this case, there's no choice. All right, we only have SSA, so we have to stick to it. All right. So from the question, we only take this one. So theta will be 98.5 degrees. We have to take this one. 98.5 degrees. That is the obtuse angle theta in red. All right. So finally, to get the bearing, that would be because we know this 50 degrees in purple is the same as this 50 degrees in purple. All right. So the bearing answer will be 98.5 subtract 50. All right. The bearing, the answer to this bearing will be 98.5 subtract 40, and that subtract 50, and that goes to 48.5. This is the answer. All right. We have 98.5 degrees subtract 50 degrees. All right, and that goes to this answer. All right. So this is the answer to the second question. All right. Number one, now there are 2 points to note. Number one is the bearing of T and P from Q. All right. Oops, sorry. When we talk about the bearing of an elevated point, we use the ground projection to represent that point. That is number one. Number two is more general, is on the SSA situation, on the two solutions in sine theta. Now, normally, there's no way to tell. Normally, there's no way to tell. You have to include two answers. But in this case, because it is stated explicitly that this is an obtuse angle, so we take the obtuse answer. All right, we take the obtuse answer. All right, okay, once again, there is another misuse of equal sign. Some of us wrote theta is 81.5 degrees equals to 98.5, right? This is a clear violation of the equal sign. All right. In fact, you mean theta is 81.5 or theta is 98.5. In fact, you mean this. All right. This is what you mean. This is what is in your head. But in your writing, you put out something like this. All right. In your writing, you put something like this, and that is obviously apparently wrong. All right. 81.5 can never be 98.5 because you did not mean this. You meant this. All right. So we be very careful about the writing, about your communication, about the expression. Do not omit this. All right. If you omit this, that is obviously a wrong statement. All right. Actually, you mean this. Theta is 81.5 or theta is 180 minus. All right. So be careful about this. 2 points in this question too. Even though you are correct, right? Try to discover some mistakes made by other people. All right. The first is the identification question, where the bearing angle is. The second is the SSA sign formula, the multiple solutions in the SSA sign formula. Okay. All right. So that is the second question. Now let's move on to the third question, and we can take a break after this one. Now the third question is the most difficult one among the 3 questions, right? The major mistake being that some of us mistook the right angle here or there. All right, so the question says it is an equilateral triangle. Now it's good that many of us catch this equilateral. All right, this is an equilateral triangle. It means a lot of things. It means that these are 4, right? Because the whole line is 6 units long. It is equilateral. So all 3 of them, they are 6. So that means this is 4 units long. All right, this red part is 4 units long. And if you notice the color, let me make it thicker. This red line is 4 units long. It's actually this one. All right, this is 4 units. And if I put this in blue, this blue line will be this one. All right, so in blue, we have 2 units, 2 cm, all right? In red, we have 4 cm, all right? And then we have angle BDA equals to 100 degree in this opening. This one is a 100 degree. This is a 100 degree angle, all right? So we want to find the distance between AB in the dotted line. So the focus triangle will be this one. Sorry. Blue is 2 cm, red is 4 cm, and then the line AB here, right? We can use a simple SAS cosine formula to do that. This is 100, this is a 2, this is a 4. So we can use SAS cosine formula. To obtain the answer will be 4.77 cm. All right, we have SAS cosine formula. So this is BA equals to 4.77. All of us are correct in finding this BA. All right. Now the problem comes in the second part. Find the angle between ADE and the horizontal plane. Now, first of all, some of us misidentified. She found the wrong angle. She identified this to be the answer. All right. The angle between ADE, this triangle, and the ground. All right. She identified this as the answer, and that is wrong. Right? If you make this mistake, then it's not necessary to look at your calculation anymore because you misidentified the angle. It shouldn't be angle DAB. All right, angle BAD is bad. It is not the right angle. It's bad. All right, it's not the right angle. It's not the correct angle in this question. all right, because it is not the angle between the two planes, all right. The angle between the two planes, in fact, should be the one at the middle. All right, if you draw the middle line, because it's left-right symmetric, so we can draw the middle line. You can draw the middle line from A all the way to the midpoint of BC. So I will first let MN be midpoint. That's how I write down the definition, all right? Be the midpoint of DE and BC respectively. All right, that's what I'm doing here. I try to define my symbols, all right? So I say this is point M, right? And then we have a point N right here, all right? And then we can join them. And then finally, we can join MN, all right? If you put down the triangle AMN, you discover that it is in fact a right angle triangle. The green line will be here, and the pink line will be here. All right, this is a triangle AMN. This is a right angle, and this is the required angle. Then the required angle is angle MAN. All right. All right, so this is how it's being done properly. Many of us do not have all this. All right. Many of us do not have all this. Now, it is correct in your calculation, but it is poor in your communication. All right. That's important in answering an exam paper. It's not just the answer. It's not an MC question. Right? Even though you are correct, right? Pay attention to this one. Pay attention to things in this box. All right. It's about proper identification. Many of us do not have this. Many of us do not have this, even though your calculation is correct, even though you get full marks in this part. All right, but there is one thing you can improve is to better communicate your answer. All right, so MN are midpoints of DE and BC respectively. So the required angle will be angle MAN. This is the angle between the triangle ABE and the ground ABC. All right. So how about the pink line and the gray line? The pink line and the gray line, in fact, they are legacy from the previous triangle. All right, the pink line actually is this one. All right, and the gray line will be this one. You can find out all the legacy from the right angle, from the equilateral triangle. This is point M, and this is point N before the folding. All right. Okay, so one last mistake. One last mistake. Even though some of us managed to get everything up to here, right? She made the last fatal mistake by saying that, okay, so angle, sine angle MAN equals to the gray divided by the pink, MN divided by MA. Right? This is one last fatal mistake that many people were making. And that is wrong. That is wrong because you make the same mistake that I just made. I made the mistake that this is a right angle. All right. In fact, this is not a right angle. It looks like a right angle, but it is not a right angle. This one is the single most important thing I want to emphasize in this particular homework. All right. It looks like ANM is a right angle here, but in fact, it is not a right angle. It is not a right angle, all right? As you can see from the three-dimensional diagram in SketchUp, if you look at it from the side, if you look at it from here, you discover that this is not a right angle, right? Because of this opening, this 100 degrees does not facilitate a right angle, all right? So if you wrongly assume this is a right angle and then you have sine MAN is something like this, then you will make the mistake, all right? So the proper way to do that is not to assume the right angle, but you have to calculate the green line as well. This is not a right angle. Let me clear this mistake, all right? In fact, MN should be kind of like a bit obtuse over there. It should be a bit kind of like this. All right. If you draw the triangle like this, you will not miss this answer. All right. So you should use a triple S cosine formula. Triple S cosine formula to find angle MAN. I leave it to you as an exercise for those who fail to complete this one. The answer is 27.7 degrees. Okay. That is the answer to part A2. So the pink line, you can find it from this triangle. All right. The gray line, you can find this from this triangle. The green line, you have to find it on triangle ABC. You can use Pythagoras theorem because you have AB from part A. All right. This is 4.77. And then half of this will be 3 units. All right. These are BN will be 3 units long. So you can get the green line from this right angle triangle. All right, you can use this right angle triangle to get the green line. This is point B. All right, we have this 3, we have this 4.77. All right. All right, so it is like this. Okay. You have the green line, the gray line, and the pink line. Then you can use triple S cosine formula to get angle MAN. All right, so this is part A2. All right, my single most worry is part A2, and the worry among all the worry is this right angle. All right, or this right angle wannabe. It is not a right angle, right? But many of us took this to be a right angle. So she came up with the wrong result. All right. So this is the most important thing in that today since 8:30. All right. So finally, one last thing, right? After we talk about that, we can take a break. The last thing is on the description, right? The one word I want to emphasize most is to describe. All right. Now, how do you describe? And you have to explain your answer. Okay. Some of us put down just one statement. The area increases. All right. Just one statement. The area increases. All right. It's correct, but it won't give you full mark. All right. This description question, there are 3 marks in this description question. You have to describe what was the area when the angle is 60 degrees. What was the area when the angle is 100 degrees? You have to describe, all right, in quantity, if possible. So when angle BDA equals to 60 degrees, all right, what is the value of the line BA in this case? All right, what is the value of the line BA? So when angle BAD is 60 degrees, the line should be, BA should be 3.4641, all right? And when the angle goes to 100 degrees, the line is 4.7727. And that with the line like this, what is the area, the corresponding change in the area? Right? The area changes from 5.196 all the way to 11.136, right? That is the description. That is the description, all right? And in this case, a simple description because it's always increasing. Sometimes the description may be more difficult because part of it may go up and then it comes down. So you might insert, say, for example, a 90 degrees. All right, so it goes up and then it comes down. Something it might be like, sometimes it might be like this. All right, but in this case, it's easier because it's straightforward increasing. So that is the description. That is the description. All right. Some of us do not know what to write to describe. All right. This is what we call describe in quantity because we can actually calculate the result. So why don't we just calculate the result? Describe in quantity when BAD is 60 degrees, when it increases to 100, what are the corresponding changes in the area? The description is the area changes from 5.196 to 11.136. That is the description. Okay, so explain your answer is your calculation. Probably you calculate BA and then you use Heron's formula, whatever, to calculate, all right? Explain your answer is to show your calculation step. Show your calculation step. This is to explain your answer. Some of us gave the description too briefly. The area increases, right? That's too brief. Some of us give a description, but no explanation, all right? So you need to have a description. This is a description. And then you have to have an explanation. This is an explanation, all right? So these are the 3 homework questions, all right? I'm sorry I took too long. I should have I should have done it faster. But anyway, these are the 3 homework questions, and I hope I tried to highlight some of the more common mistakes. And you know, I hope you will avoid the same mistake later on. I will post these slides onto the Edmodo afterwards.